In this video, we're going to be doing right triangle trigonometry. Specifically, we're also going to look at the pi over 6 or 30 degrees, pi over 4 or 45 degrees, pi over 3, which is the 60 degrees. We're going to use cofunctions of complementary angles. We're going to do an applied problem. So we know from previous math, or if this is brand new, we can define the sine as the opposite of the hypotenuse. I prefer actually to define the sine in terms of x, y, and r, where this is the y value over the r value. Similarly, I did the same thing with cosine. I prefer this as the x over r and the tangent as the y over x. And the reason is because when we get further into this class, we're going to move further away from hypotenuse, adjacent, and opposite, because that's only true for right triangles, and most of this class is not going to be on right triangles. Now, what we know when we are working on the unit circle, when the radius is equal to 1, then my sine is just going to be equal to the y value, and my cosine is equal to just the x value because my radius was 1. What we know from being on the unit circle then is that we can think of on the unit circle, this is the cosine of the angle when I'm on the unit circle, and this is the sine of my angle when I'm on the unit circle. So as an example, if t was the pi over 3, my ordered pairs for on the unit circle is 1/2 and the square root of 3 over 2. And so what we know, that tells us that the cosine of pi over 3 is 1/2 because that is the x value. And then the sine of pi over 3 is the square root of 3 over 2 because that is the y value, just as a refresher. So I like to use x, y, r rather than the adjacent, opposite, hypotenuse. When we're asked to solve a problem with a right triangle, we know it's a right triangle. What I typically do is I will draw my triangle in the first quadrant so that I'm thinking of x, y, r. Of course, I'm just going to use r here instead of 1 because we don't know what it's going to be, so we're not necessarily on the unit circle. But I do like to place my triangle of interest in the first quadrant so my x and my y are both positive. And then it's a matter of thinking about the ratios of x, y, r to the angle, depending on which one I'm looking for. After I have set it up in the first quadrant, my origin is where I put the given angle. So if I have a given angle, I always put it down here in the origin. Then I set up the ratios to solve for the missing sides. So let's go through a couple of examples. In my example, they tell me that I have the cosine of beta. So I'm going to go ahead and draw my triangle. Does not have to be to the correct size. I just want to put it in place. I put beta here right by the origin. That's where I'm going to put beta. And we know opposite beta is b. We're going to call this y, however, just so we get used to the x, y, r. Opposite the alpha, that's this one, is going to be a, but we're going to call that x. And then, of course, opposite the 90 degrees is that 90 degrees is gamma. And so we call that c, but for it, we're going to call it r. So we start to get that relationship between x, y, and r. Now they tell us that this side is 10. That's 10 right there. And so what we're asked to find is this y side and this r side. We use the fact that we know that the cosine of my angle is the ratio of 4 to 5. So what we know is that if I have the ratio of 4 to 5, that is the same thing as the ratio as x is to r. Now we know what x is. X is 10. So 4 to 5 is 10 is to r, which is the side C, the one that we're trying to find. So all we have to do is solve for r. So we'll multiply both sides by multiply both sides by 5 and by r, and then divide by 4. So r is going to be equal to 50 divided by 4, which we know is going to be 12.5. Okay. Now what I want to do is I want to find my other missing side. So we found the side C, or the radius if you prefer, which is 12.5. We need to find my side B, and the way that I can find my side B is using the fact that we have Pythagoras' theorem. My radius squared is equal to my x squared plus my y squared, or c squared is equal to a squared plus b squared. We know what the r is. The r is 12.5. And so we're going to take the 12.5 and square it. We know what x is. That was the 10, so that's 10 squared. And then plus y squared. Solving for y is going to be the square root of, I'm going to get my calculator out. I'm going to square 12.5. And then I'm going to subtract off 10 squared, which is 100. And I get 56.25. Now I'm going to take the square root of that, and because I'm really chasing the square root of that, so 56.25, and I end up with 7.5. So my y value is 7.5, or in other words, my b value is 7.5. So b is equal to 7.5. Let's take a look at the next example. So I'm going to do this here. So I'm going to draw my triangle. Again, I draw my triangle so that I am in the first quadrant, y and x. They're giving me alpha. I always, by default, put alpha or whatever angle I'm known on the origin there. So I'm going to call that alpha. That means that this is A this time. I'm going to call it y. That means this must be beta. Beta, not B. Beta. That means this is B, which is my x. That means this is my gamma, which is my c, which is not my gamma. Excuse me, let me erase that. It is my c, which I call r. And then, of course, gamma is the 90-degree triangle. So once again, I know information here. I've got my beta, or my b, which is 6. And I have the relationship for tangent. Tangent of my angle is going to be 5 over 12. Now, what I also know is that is the ratio of my y value over my x value. So I have 5 over 12 is equal to my y value, which is what we're trying to find, over my x value, which is 6. That's given to me right here. That's my 6. I'm trying to find my r and my y, and as before, I set it up with the fact that I have the ratio between y and x as 5 over 12. And I have the x, so I know that when I set this up, I can solve for y. I'm going to multiply both sides by 6. So I get 30 divided by 12. So in other words, I get 5 over 2 is equal to y. So I have my y value. Once again, I know that r squared is equal to x squared plus y squared all day long. I'm chasing r this time, and so I have r squared is equal to my x squared, which is 6 squared, plus my y squared, which is 2.5 squared. My r is the square root of 36 plus, and so I do 2.5 squared, 2.5 squared, and I get 6.25. I add those two together and take the square root. So the square root of 42.25 is equal to 6.5. So r is equal to 6.5. So I found all my pieces. My pieces are my r, or my c if you prefer, is the 6.5. My a, or y, is going to be equal to the 2.5. And I've found all my pieces. Now let's take a look at my last problem here. And my last problem here is they're giving us the alpha and they're telling us what c is. Okay, so as before, I'm going to go ahead and draw my triangle on, not to scale of course, y and x. They're telling me this is pi over 4. So what I do, since I don't have anything else but that's pi over 4, is I go to my unit circle. And I look on my unit circle and I look at sine and cosine. Now my c, which is what they're given to me, which is r, is 12. The sine of pi over 4, the ratio is the square root of 2 over 2. That's the same thing as the ratio of my cosine. So I'm going to do as I did before. I'm going to have the square root of 2 over 2, because this is equal to my y value over my r value. is going to be equal to my y that I'm chasing over my r, which is given to me as 12. So I go ahead and multiply both sides by 12 and divide by 2, and so I get 6 the square root of 2 is equal to y. Because of the fact that this is a 45-degree angle, this also has to be a 45-degree angle, which means my y and my x must be the same thing. So my b, which is equal to my a, which is equal to 6 the square root of 2. Now again, I prefer x, y, r, but this is asking for a, b, and c, so we'll go that way. Now let's take a look at this example. There's an antenna at the top of a building, a location of 300 feet from the base of the building. The angle of elevation to the top of the building is measured at 40 degrees. So once again, I'm going to draw my picture, always in my first quadrant, y and x. They're telling me the angle of elevation, that means as you are standing there and looking up, is 40 degrees. So there's 40 degrees. And we're a location of 300 feet. So you're standing 300 feet from the building. So this side is 300 feet. What they want is, let me see, the angle of elevation is 40 feet. Measured from the same location, the angle of elevation to the top of the antenna. So there's an antenna on there. So I'm going to put this antenna on here. This is my antenna. It's not a person, it's an antenna. That angle is 43 inches, or 43 degrees. So that angle is 43 degrees. We want to find the height of the antenna. So what we need to do is we need to do this in two pieces. First, we need to find this height. And the way that we're going to do that, and that's my y value, is I know that I'm going to use the tangent. And the reason I'm going to use the tangent is because I'm given this x value, I want this y value. I don't care what this r value is. So I use the tangent, and I'm going to use the tangent of 40 degrees. It's going to be the relationship of my y value over 300. So I know this initial height is going to be, make sure your calculators are in degrees. So that's a mistake that's really easy to make. So I'm going to make sure I'm in degrees. And I'm not, so I need to change my calculator into degrees. And then now what I'm going to do is I'm going to do the tangent of 40 degrees, which is 0.8390-ish. Now I'm going to multiply that by 300. That tells me the height of the building is 251.7. I'll go out to, let me see, rounding. So we'll go out to 299. So that's the height of the building. Now I'm going to do the same thing so I can find the height of the building plus the antenna. So I'm going to call this y2, and I should probably call this one y1. What I want, this is my want. My want is to take y2 and subtract off the y1, and that's going to give me the height of the antenna, because that's what I'm really chasing. So I'm going to do the tangent of 43 degrees is equal to my y2 over, and I'm still standing 300 feet away. Again, I'm going to make sure I'm in degrees, and I'm going to do the tangent of 43 degrees. So the tangent of 43 degrees is 0.9325 something, something, something. I'm going to multiply that by 300. And so when I do that, I've got my y sub 2 is equal to 279.7545. Now, what I want is the difference between the two. So I'm going to go ahead and find the difference between the two. So this is going to be equal to the 279.7545 minus the height of the building, because my y2 here is the height of the building plus the antenna, and all I really want is the antenna, but I had to find the total height. So minus the 251.7299. So I'm going to go ahead and subtract off those two numbers, and I get 251.7299, subtract those off, and the height of my antenna, which is the answer that I want, the height of my antenna is 28.02, let's run it out to 4 decimal places, 46 feet, and that's my final answer. So that is my final answer. Okay. Nice application there. I got to use tangent. Normally we use sine and cosine. This time I use tangent. Nice application. Let's Let's look at cofunction identities. What cofunction identities? It says basically, here's the gist of it. The cosine of the angle is the same value as if I took the sine of the angle and subtracted it from pi over 2 or 90 degrees. So in other words, what this is telling me, what these two are telling me is if I want to know the sine of pi over 6, it's going to give me the same answer as the cosine of pi over 3. Okay, so that's what that's telling us. Similarly, for these cofunctions, if I want to find the cotangent of pi over 3, this is going to give me the same value as the tangent of pi over 6, or 60 and 30 if you prefer. The secant is also telling us the same thing. If I want, and this time I'll use degrees. If I want to know the secant of 41 degrees, I know that it is the same thing as the cosecant. And I take that 90 and I subtract off that 41. This is where I'm getting those angles, and I get 49 degrees. That those are going to give me the same values. That's what it means. So when I come down here and I'm asked to find the cosine, if they give me the cosine of pi over 3 and they want me to find the sine, well, we know that those two angles have to add up to pi over 2, that whatever this angle is right here, that angle in question plus pi over 3 has to equal pi over 2, or in other words 90 degrees, so we know that this has to be pi over 6. Now the great thing about the pi over 4, which is a 45, is tangent and cotangent are the same value. Same thing with sine and cosine, same thing with secant and cosecant. We love it when we see the pi over 4. So that's kind of nice. Anyways, that's it. Nice quick video for section 5.4.